First of all, I welcome the opportunity to be able to speak in front of a group like this. The presentation that I'm going to go through, I made for this presentation, so I haven't given it, and I threw it together, and I really try to put it in perspective that there's going to be hopefully some things you're not familiar with but interested in, especially from a foundational aspect, you know, because there's computers everywhere and they run on power and cooling and there's monitoring involved. It's foundational. People take it for granted and sometimes they don't know what goes on behind the scenes, and I've worked with a lot of software people before, and you know, it's always great to take some software developer into the data center and they see what their application is running on, and they're just amazed, you know, seeing a blade server or the storage and the network systems, and it's really great to show off those kinds of things. So I thought I'd talk about monitoring because that's probably a huge link into software development. In the facilities world, a lot of times we have to take care of our own monitoring, and we almost have to become software people because we're just left on our own to figure everything out. And I don't think that's too unusual in the software world. So we're going to talk about, and we thought we'd title it, Is Your Infrastructure Working Properly? Now it's going to have a heavy facilities focus, but I am going to talk about a lot of other types of monitoring of databases and applications and everything that's out there. I'm not going to deep dive them, but I'm going to show that it's a really complex world. There's a lot out there, just like everything, and it's confusing. You can't be an expert at everything, so how do you sort it all out, and how do you understand it, and how does it all relate? A little bit about myself. I work for Online Tech. I've only been an employee for about 3 months. Prior to that, total I have 23 years of experience in facilities and IT. So by degree, I have a Bachelor of Science in Electrical Engineering, and I have a business degree, and I started out in the manufacturing world. Going backwards in time though, right now I'm a data center engineer. Our company has 5 data centers, and we have to take care of all the facilities, which includes, you know, critical power, cooling, and fire systems, and everything with the data center white space. Prior to that, I did the same sort of thing for Trinity Health, and Trinity Health owns St. Mary's. That's one of the hospital systems that they actually own. So I've actually done a lot of work in that data center over there. I've replaced UPSs over there and AC systems. And prior to that, I worked at Ford Motor Company, and I was an IT supervisor for several years. And that really was my dog years of experience. It was a tough job. You're responsible for a lot, and that's where I learned a lot of things about the data center, desktop support, networks, plant floor systems. And how I got into the IT world, before that I was straight manufacturing for engine operations. So I bought machinery, got into material handling, and then I got into the CAD/CAM CAE world, and that was kind of my hook and my link into the IT world. And prior to that, right after school, I kind of started out as a electrical project engineer, and I did power distribution and controls. So all that background is really actually good for the data center environment, an IT environment. So we did an abstract about it. You've read this. So it's, you know, monitoring is some essential part of operations for data centers. I mean, what you have in there, you know, critical power, cooling, fire systems, all that has to support the hardware in there. It has to protect it. You know, there's security issues there too, and you know, how do we know it's working right, or if something's wrong? What can you do? So we're going to talk about monitoring systems from a facilities perspective, and kind of the history and what I've seen through the years, how that's grown. Some other things that came maybe from like the manufacturing world for monitoring, and things that have come from like traditional buildings outside a data center for building management systems, and how those have migrated, and how this kind of relates to more advanced up-the-chain monitoring of applications, databases, and so on and so forth, because there's a lot of similarities. So when I talk about facilities infrastructure for data center, there's a lot out there, and I've listed all here, and should be familiar with some of it, but maybe not. But I thought I'd go through just the types of things that are out there. So when we talk about critical power, there's a thing called UPS, uninterruptible power supply. That's what keeps the power good. Usually they're dual conversion UPSs, so they break down the power and they build it back up, and you get a nice clean waveform going out to all the devices. We have power distribution units and the power strips, which are cabinet distribution units, although some people also call those PDUs, but they're just power strips that are in the cabinets. There's all kinds of breakers and electrical infrastructure to deal with. When we talk about critical cooling, because these items give off a lot of power, so you have to keep it at the proper temperature so everything works. And there's just all kinds of cooling systems, from chilled water, computer room air conditioning, which are called CRACs, DX units, direct exchange, dual systems, glycol systems, which a glycol system is just like your car. It's basically like a radiator with coolant going through it, pumping it through, to reject the heat. Big thing now is like air economization, for efficiency and everything. California has just passed a law, and I think it was effective the last July, but basically you have to have some type of air economization in any cooling system that goes into a data center from now on. So to me that's a big deal, because I think that's eventually going to catch on to a lot of areas, and maybe within the next 10 years that just might be every data center in the US possibly. Or people might say, forget California and all the data centers are going to move out of there. But there's emergency power, and there's a lot just with that part of it. So you have generators, typically diesel generators primarily, because they can start real fast, versus natural gas. Plus, some people feel like natural gas supplies can get cut off, and then what do? You can't really store natural gas on site, but diesel you can. To have X hours of fuel available to run. You have automatic transfer switches, which are just big switches, and they transfer between your normal and emergency power, but there's a lot of different types of those, and that's a real key part because it tends to be a single path of failure. So you have to understand those and take care of those. Then all the fuel systems, diesel fuel only has a shelf life of so long, and it's different than gas. It can lose its properties and get gooey and clog up the filters, so you have to understand how to take care of diesel fuel and monitor it and clean it and polish it and all that. You have fire systems, which are critical, and there's a lot of tiers of fire systems. You have things called pre-action, because you don't want water in the pipes if someone accidentally breaks a head. Well, water does not mix with electronics, so you want to hold the water back and only put it into the pipe when it's actually needed, so that it's available and becomes a regular building sprinkler. You have gas systems, which aren't as disruptive, because water doesn't save the hardware. Water just saves the building, but more people, the hardware is what's more important to most people. And the gas systems can actually save the equipment. And then you have sniffer systems called VESDA. I don't know what actually VESDA stands for, but it's like an air sampling system, and it's so sensitive it can start to pick up burning electronics before even a dog could smell it. So that's like on the front end of trying to figure out if something's wrong before it actually happens, and try to find out what's going on. You have power systems that support the UPSs, because they have batteries and there's a lot of different types of battery systems. And there's valve regulated lead acid, which is common, but those only last several years. There's wet cell, which are for bigger systems, which can last up to 25 years, but they're very expensive, and somewhat more stable. You have flywheel systems that are just a mechanical battery that is a spinning motor basically, and it can supply DC power. So those systems are really neat, because some of those systems are actually spinning at 50,000 RPMs in a vacuum. And people just, I mean, it has to be, the balancing has to be so perfect if it's just off a little bit. I mean, something with that much energy and spinning is just, kind of incredible to see. Then there's a lot of data center specific items. I mean, there's leak detection to take care of because any moisture of any type in the data center can ruin equipment. And just not ruin equipment, but water damages things, so you don't want your raised floor damaged and having it, the stanchions come loose and have it collapse, either people or equipment. There's temperature points to monitor, just not at the ACs. You might want to know what's going on in your cold aisle or hot aisle, or at the point where it's really important and know what's going on there. Data centers tend to be part of office buildings. Not always though, but even if you don't, you typically have regular rooftop units and HVACs to take care of, or somebody else, but they're there. Someone has to take care of them. You have a variety of security systems, all kinds of badge reader systems, burglar alarms. You have video systems. If they're large enough, you might have cell phone repeaters in there, if you don't have good coverage because of the grounding of the building and the construction of it, and people need to be able to use their cell phone right in front of the rack. It's actually a big problem if you can't use a wireless phone now. Pager systems, you still have those because of that problem. Cell phones still don't work in a lot of areas, and I can attest to that because the hospital systems are horrible for cell phone reception. So that's why, in my mind, pagers still exist. A big reason for that, because they work in those areas. But pager systems are migrating to the phones and everything, but a pager is still a big part of monitoring systems even today. You have a lot of water makeup systems for various reasons. If you have a chilled water system, you still have to replenish that water, but not as much as like an open water system where you're evaporating using that. And there's a lot of problems with water because there's stuff in water. There's minerals and deposits, and you have to take care of that because it builds up, and then you don't want the water building up with algae or bacteria or anything like that, so you have to treat that water. Then there's also systems that use reverse osmosis DI water, which is just a fancy term for a high particle filtration of the water to get it really low, and then a deionizer to take the minerals out, because you have some systems that use ultrasonic humidification. So they need a very pure water to be able to use that, or those systems don't function properly. So that was just a brain dump of everything that I thought was facilities. I'm sure I probably missed a few things, but there's a lot out there that's just the data center base infrastructure. So now let's go what's inside the data center that you take care of. All that other stuff is support to take care of devices. So what do you have out there? I just did a brain dump of the kinds of things that I see. So I classify, servers, and there's all types. You have your open system servers, your Wintel type servers. You have blade servers of a variety that are real high density. And does everybody know what a blade server is? So those are really, really high density racks. So just like one rack typically can carry up to 4 chassis, 16 servers per chassis. And you can get like up to 5 kilowatts per chassis. So it's common to have 18 to 20 kilowatts of power just in one rack space. That's an insane amount of power to cool. So that's some of the highest density devices that I've seen on the floor. And you really get into a big problem of cooling something like that. You have to go to supplemental high density cooling to do it properly and efficiently. Up to about 6 or 7 kilowatts a rack, you can do traditional cooling, under the floor. Beyond that, it gets the efficiency just nosedives. And everything's just getting more dense, so high density cooling is really becoming a big thing to do that properly. Network devices of all kinds, and I just did it brained up here. Routers, access switches, core switches, bandwidth analyzers, balancers, server switches. You have your SAN storage, which to me, when I first started to see those devices, they have their own network infrastructure. to take care of. Plus they have the arrays and everything and consoles to access and control them. You have, typically in data centers, you have security areas that are isolated for DMZ walls or security devices. So there's all kinds of, and that's where you see things called like appliances. And I always get confused, what's an appliance when I first heard of it? I thought, a stove was coming in or something, or microwave, but it's just kind of like a package server type thing. You see a lot of them in the security areas, and I think they're used for email and firewalls and things like of that nature. Then you have telecommunication areas in the data center because everything's going IP-tel. So I've seen those conversion happen for company, and what happens is all of a sudden a data center needs 4 or 5 racks just for IP-tel. And that's a big problem for a lot of companies because that wasn't really accounted for that power. A lot of those devices use power over Ethernet. So if you have a network closet that you're going to power phones out of, usually didn't have the cooling capacity in it. So that's what people struggle with, and they still do when you see that conversion. Because when you use power over Ethernet, well, that heat generates out of the switch. So you have to take care of that. I mean, if you're designing a new network closet up front, you just have to know that you're good, but not everything is new. You have to convert everything, so that's still occurring out there. Then I just put this other area, legacy equipment. I still see stuff that's just ancient out there that you're like, what is it? OS2, what operating system? Then you have stuff like no one even knows what it is. So there's still some of that out there. The next part, and you're going to see this theme going throughout, I don't really recommend specific softwares. I always go back, and this just doesn't apply to softwares. I say, what features are you looking for? Get all the features that you want, and then list up all the different software that are out there. Get a matrix, look at it, and then pick something or a couple of them that meet your needs and test them out and go down that path. So, and I love Wikipedia for everything. I know some people don't like it, but I go out there for everything. And these are some good links because that's what these matrices are for network monitoring. If you go to this link, what you'll see for network is all the features that they've listed that are listed out. So we have all these things, and some of them, I'm not familiar with all this terminology, but I just throw it out there because I think things like this are great because I've been through a lot of initiatives where people start from scratch on this. They don't go to see what's out there and just build from there. But I see a lot of companies just try to do this on their own. It's really hard to do. So if you take information that's out there, I think it's a real good starting point. So there's a lot of things I'm familiar with, like SNMP and the features. I'm very familiar with that from a monitoring perspective. I'm going to talk about that more. But if you just look at the products that are out there, I've highlighted a few because those were the ones I was familiar with that I know companies I've worked for have used, but the rest I haven't heard of. So I just thought that this was interesting to throw this out there to show you what's in the network monitoring world and how much is out there. And this just continues because there's more products there. And I've also highlighted PRTG because I was familiar with that. Actually, the company I work for now uses that product. And SolarWinds, I highlighted that because that was one of the first monitoring products that I ever used at Ford Motor Company. And we just used it in a simple way. We just used it for the pings. You just ping devices. And that's all it did was when it didn't ping, then you assume that it's not working, go fix it. So we were pinging network switches, anything that had an IP address. And that still is so powerful today, especially when I see like website monitoring. What are they doing? They're just pinging the website, and if you lose the ping for so long, it notifies you. So it's the basics like that are so important because I never see things like that getting unimportant. It's just always going to be there. Ping is so powerful. And when I had to deal with network switches, my first day on the job at Ford Motor Company, a network switch is down in IDF. And I'm like, what's an IDF? And then I'm like, what's a switch? But I'm like, okay, where's the network person to fix this? And they're like, it's you. So 17 hours later, I had to learn what a switch was. That is like a computer. There's a program somewhere. I had to find it. I had to reload it. I had to get it changed out, and I had to get it back online. So in the world that I'm in, I mean, that's common, that all of a sudden you're responsible for something, no training, no information, no vendor support, and you have to figure out how to fix it. So this is just the legend of that explains further on the features in more depth in case you wanted to know. But anyways, I'll be giving this presentation out and it will be distributed. So that's why I just include a lot of the information so that if you're interested, you can go back and get the details or go to those links. Okay, website monitoring. Same thing. Here's all the features in website monitoring products. So I was kind of, I just pulled this up and I thought it'd be interesting to present. You're probably familiar with this, maybe not. But I was familiar because there's only one tool that I've seen warmly. We actually use it for my current company because it's very important for the type of company I work for now, and this is the first co-location company I've ever worked for. So I've never had to use a product like that or seen a company use it. And all it's doing is basically pinging the websites and tells you when it's down for 5 minutes and then when it's back up. So I was interested to see this and see the features, free use, the interval that it can do, the websites per account, the nodes and the emails alerts, text type alerts, can have push alerts through mobile apps, and it can monitor all those protocols. So I thought this was kind of interesting for this group to share that with you. And again, it goes into more depth about what they're talking about, what a node means and everything. So here's the next thing. And I want to talk about application monitoring. How I used to do application monitoring was just old school. Go to the application, can you get to it? Send some data to it, can you pull it up? Is the server that it's running on pingable? So when I think of application performance monitoring, I start there. And I've been involved with testing software and development. When I worked at Ford in the CAD/CAM CAE area, they had this product, Viz Plus, and what it did is it took the 3D solid CAD image from SDRC, which was the CAD software, and it would strip it and make a 2D image out of it so that you could use it on a Windows product. So that program, Ford was heavily involved with developing that product with the software developer, and I had to actually do testing for it. So I went, what kind of test plan should we do for this? I went back and I kind of went midstream in a development cycle, and I'm like, well, what were the specifications? What did we say we wanted? I went back to there and then, just had examples of, okay, well, this is what we're going to do to test it because this feature, we're modifying, so let's make sure it works on everything, and, let's pull it up. So when I think of application and if it's working correctly, that's my history. I think of that, but it's a lot more than that. And it's really hard to tell if an application is working. I mean, I think that's the hardest thing out of anything between databases and the network and infrastructure is how do you know your application is working? And that's why I'm just like, well, go log into it and pull data and get it back out. So I found this concept. I've been to a Gartner conference before, and this comes from a Gartner concept of application performance management. I hadn't seen it. I just found this for this presentation, and I thought it was interesting because they seem to have a methodology that was based on a lot of things. And when I saw this end user experience, I kind of thought, well, yeah, that's important. So they had all these dimensions, and to me this is, how do you know if your application is working? So this is something that I get into a deep dive to help you do that, and you can tell that it's a very, very tough problem to deal with. But they have different dimensions, and I thought all these dimensions were interesting, the area of focus and the potential benefits. So I don't know how common this is. I mean, has anybody heard of this before, or this concept from Gartner? So it's out there. Well, okay, they didn't create it, but they tout it through their conferences. But anyways, this person created it right here, Larry JJ. So I gave him credit for it. So anyways, kind of the last area that I wanted to talk about that was outside of facilities is database tools in general. And there's a lot of links out there. And I just started to look at the features, to understand what they're looking at. So this is another link to another matrix that goes for database. So I'm sure you're familiar with a lot of these tools. But just when you start to put it out there, I mean, there's a lot out there. When you look at all these areas, and it's like monitoring is a big world. How can you be an expert in monitoring? I mean, very tough, and it's just evolving constantly. But again, I always go back to basics. What do you want it to do? Go find what tools can do, and then try to get like your must-haves and then your wishes, and try to match it up and then go there. Just don't go to a software vendor because they were recommended to you. Get something that you really need and really, really go there. So there were actually there were a lot of different features and products. Now back to the facilities part of it. I wanted to start with something that's called a building management system. Very common terminology. Has anybody ever heard of that terminology? And really, what you see out there, a building management system was not made for a data center. It was made for commercial buildings, because you have a lot of things in the building, but it's computer software, and a lot of them are complex and proprietary. But traditionally, they were built to control like HVAC, plumbing, heating, cooling, gas, just everything that's associated with the building. And what I've seen out there for some data centers, and this isn't so much the case nowadays, but you might see a building management controlling data center infrastructure. And in every case that I've seen, it's just a big mistake. And the reason why is because someone else is outside of IT or IT facilities, it's probably straight facilities, is controlling it. So now you have these lines of demarcation that are gray, like when something breaks, who's responsible for it? The right people don't get the right information. These systems that weren't made for crack units or UPSs, now all of a sudden they're monitoring them, so they're kind of had to develop. So all the ones I've seen, they're kind of, and BMS systems are complex and hard to use. So I'm not a proponent of the building management system controlling data centers completely. I am a proponent, though, to interface with them and send certain signals as a secondary level of alerting. So if you have your data center monitoring, and as a backup, if there's a temperature alert, we'll send it to the building management system as a summary alarm so that they know about it too, just in case the primary fails. And that's a big thing that a lot of data centers miss. They don't have a secondary means of monitoring. They just rely on one means, and if that means fails, well, you need redundancy in your monitoring too in a lot of cases. And a good example of that is like leak detection. If you're familiar with leak detection, there's two main types. There's rope leak detects that work off the capacitance, and there's point detects. But the problem with ropes is they're usually very, very long. You might only have one or two or three in a data center. And the ropes, when they go off for a leak detect, they usually give you the footage that it's at, but you never see good drawings. You don't know where that is, and all of a sudden you're popping all kinds of floor tiles and hunting down the rope to look for it. The kinds of leak detection that I've seen work the best are multiple systems. So, and the problem with the rope leak detect too, if it goes off, you don't know if it's a drip of water or if there's 100 gallons coming in. It doesn't tell you that. So when I put in a leak detect system, I'll put in a rope leak detect, And then I'll have point leak detect all over that's independent. So if I see a rope go off and then all of a sudden I see 3 point detects go off, I know it's a large leak and then go look for it. Or if one of those systems fails, then you still have the other system so you know what's going on. And I've seen many, many data centers flood out for various reasons. Backed up sewer lines, broken, water pipes coming in, and it happens. It happens a lot, and when it happens, it's almost as bad as fire. So anyways, I want to talk about the BMS because there's a lot of roots there. There are a lot of data centers that are controlled by BMS systems. I just want to make you aware of it. Another concept that really came from machining, but I think a lot of things that come from the machining world are relevant to facilities and relevant to data centers. So there's a thing called programmable logic controllers and relay logic. Now, what is a PLC? It's really an industrial device. It can be programmed with ladder logic so that you can change the logic to control inputs and outputs. And a common one is Allen Bradley PLC 525, but there's a lot of manufacturers of PLCs. That's just one of the more common ones of the Rockwell. And then there's a lot of mini PLCs that aren't as big as modular as that. If you just need a smaller one, there's all kinds that are just dedicated. Maybe you can't change the I/O cards or anything, and they just fit your application exactly what you need. But why mention the PLCs? Because there are PLCs that are in some IT infrastructure. And the biggest example are automatic transfer switches, and especially complex ones that are paralleled. The logic behind it are PLCs. And if you don't understand PLCs, you can get in big trouble. For example, PLC has a program in it, and where's that program stored? The default for a PLC usually that it has its own little battery for battery backup instead of burning an EEPROM. And a lot of people don't know if they don't maintain that battery and let that battery die, and then all of a sudden you lose power to the PLC, it lost its program. And what a tragedy is if your transfer switch does not work when it's needed for a data center. It's a down data center. So you have to understand PLCs to know, do you have a battery or not? Try to avoid the battery. Why don't you get a burned EEPROM so that you'll never have that problem? So that's one aspect that you need to know about PLCs, just from a high level and from maintenance. The other thing is just about I/O and logic. When I first got my electrical engineering degree, I'm looking for a job, and everybody wanted somebody entry-level jobs for electrical engineers, but they wanted 2 years experience PLCs. And I'm like, I didn't even know what a PLC was then. They don't teach you that kind of thing in school. There's no class you can take. It's really something that's learned out in the field, and you can take classes from Rockwell to learn it and other manufacturers. And that's how you learn it out there in the field, but they're out there and they're important. Okay, now I'm going to kind of go through the history of data center monitoring outside of like building management systems, and I'm going to talk about some concepts. So a minimal level of monitoring is like getting a summary alarm from a device. What's a summary alarm? We have an AC unit, something's wrong with it, it just sends a signal, something's wrong. It's a summary alarm. That's like a minimal level of monitoring, but it's important because it's better than no monitoring at all. And it signals you to go check it out to find out what is going on. I mean, it could be just a minimal alarm or it could be something severe. So understanding that, because there's still a lot of things out there that you have no alarming at all, and I try to always get at least a summary alarm. Can I just get a signal if something's wrong? Network cards are big. They weren't always out there in IT equipment. But network cards are better. You can IP the card. It can give you SNMP traps. You can go over the network and look at a web page and see everything about the unit. And this applies to fire systems too and UPSs. And in a lot of cases, you can actually control the units too and do some things, just not see what's going on. Some network cards log the data so that you can look at a little bit of history. Some cards don't. You have to interface those cards with other systems applications that pull the data and can store it. Then you can do reports and look at log files and history and like that. Some network cards you can actually send alerts to emails, which is very powerful. Or those SNMP traps, which is a basic concept of data center monitoring, in my opinion, to be able to use those SNMP traps, because you can do a lot of things with those. Other programs can scrape those and interface with those, and you can interface them with other monitoring systems to set up any type of alerting system that you want, automatic or for manual triage, or for logging the data. But nowadays, all manufacturers make network cards for the equipment, for anything that's out there for the data center. And given my experience and everything, given the opportunity, I always try to get a network card, even if it's tied into some other type of system with another type of card, like a Modbus link or anything. I always want the network card as a backup, because monitoring systems fail. And when they fail, it's not a good thing. You always want a backup. I always try to get redundancy in monitoring. And I know it's more expensive, but in the big picture of things, what's a $700 card compared to a data center where millions and millions of dollars are at stake? So like I said, my first experience with PLCs and relay logic, everyone was looking for that. And actually, my first job out of college, I worked for Flint Ink Corporation, which was a printing ink manufacturer, as a power and controls engineer. And I learned about PLCs basics. I learned about relay logic, which PLC's ladder logic is just relay logic in computer form, and it's modular and changeable. Instead of having to do the wires around and everything, you just do the ladder logic around. And those are very, very basic concepts in the machining type, factory type world. So down here at the bottom, I just talked about what a conundrum it was, because everybody wanted that experience. They don't teach it in schools. How do you get it? So I looked up the definition of conundrum here, and I thought it was appropriate. It's a riddle whose answer involves a pun, or a question or problem having only a conjectural answer, or an intricate and difficult problem. But what I found most interesting in that, its first known use was in 1645, and I'm sure it was related to a facilities type person using that in 1645. Maybe the Romans when they were making the aqueduct or something. But anyways. So I'm going to go back a little bit of history, and I still see this today. First experience with monitoring and facilities with IT. What monitoring? There was none. There were devices, none out there. You actually, if you wanted to know what was going on, someone had to physically go in front of that device, get to the screen, go through it, or console into it. There was no monitoring. It was just all manual. And you still see that today. So how did things get better in facilities monitoring from that point, what I saw? Well, I've seen things with the summary alarm. I mentioned that before. So next step up from no monitoring to summary alarm. I talked about the ping before. Very, very basic concept, but very, very powerful. I mentioned SolarWinds that just monitored everything that's pingable, but it got us 90% of the way there and helped us out a lot. If we didn't have that, then we would have been waiting for someone to call us to tell us that something's broke, versus us knowing about it and going out proactively and be able to check out what's going on. And the ping doesn't tell you if everything's working, but it's a sure good indication. If it's not pingable, then it's not working for sure. Also out there, I saw a lot of temperature type devices that were just isolated standalone, all they give you is a horn or a light that goes off either locally or remotely. You know, it's not tied into anything more than that, but for a lot of companies and a lot of applications, it helped. Because if you look at some hospital systems, they only have maybe only one hourly trade on call for the whole hospital system or all the buildings. And he usually hangs out in a central area, and I've seen this type of monitoring, just, you know, a remote annunciator panel run to that place where they hang out, or a red light, so that if it goes off, then they know to go check something out. And in some cases, that type of monitoring is still, you know, relevant and useful. So I mentioned network cards from there, and that is better. To me, network cards are the most powerful thing because they can interface with all types of systems. And when we go further in this, we'll talk about DSIM and where it's going. So SNMP traps, you can look at the web page, you can go configure it, set up email alerts in a lot of cases, go look at logs. And then if it's not as a standalone, then manufacturers of UPSs like Liebert and APC and everybody, they'll have their centralized applications that can collect all that. So they're tied into it, each card that you configure on that. So now you have all that data, and you can start doing reporting and anything that you wanted, and you have a centralized system pulling those. So the thing about those systems, though, there's different ones out there. And when the UPS manufacturers and AC manufacturers first started to make those types of systems, well, it was proprietary. It was their system. It couldn't tie into, like an Eaton UPS, couldn't tie in with the Liebert UPS. They kind of like, if you bought Liebert stuff and you wanted to buy Eaton UPS, they're like, no, you have to have its own monitoring. So that was kind of the problem there. And that still exists to a certain degree within the world of critical power and cooling. But then you started to see the manufacturers, they made different systems that were more open, that could take other manufacturers' information, so that you could go buy an Eaton UPS and a APC UPS or AC and integrate them into those systems. And those systems are still evolving like that, although there's problems with that because a lot of the systems aren't packaged like that, ready to go. You might have to go to that manufacturer and say, I need the MIB file, you know, that tells me the configuration so that I can interface it. And that sometimes is a hassle to get that if they don't have something prepackaged for you.
So there's a protocol or an API amongst disparate manufacturers between Liebert and Eaton?
Well, everybody can use the SNMP, okay, but to interface with their application, you have to have that MIB file. That's, to me, how I describe it is it translates it so that you know what that device is talking about, what each alert means. So it's different for each manufacturer, and they need that translation file.
So the MIB is the magic that interconnects?
Yes. So and when you buy those monitoring programs, if you don't see it on their pick list, and you have a different piece of equipment that isn't listed there, you have to go back to them and say, I have this. And usually you have to put in a support ticket, and they have to, you know, develop one for you, and then they give it to you, you load it on your application, and then you can run that in their monitoring system. And that it's more than just like ACs and UPSs. A lot of the PDUs, which are the power strips, you can also put on the network. You can even have some power strips that you can control each outlet and control remotely. And in like a co-location environment, it's kind of important because sometimes a client wants to be able to reboot their systems remotely. And that's how they accomplish that, because they specifically asked for switched PDUs that they can control the outlets so that if they need to reboot something, they can accomplish it like that. But power strips are even worse in terms of compatibility with the systems, because seems to me like the UPS and AC manufacturers in their systems, well, they focused on UPSs and ACs. They're like, oh, you want to add a power strip to it? You know, they're starting to add them, and they're going there. But you can, anything with SNMP trap, you can pull into those systems. And now I know I think SNMP2 is the most predominant right now. You're starting to see some systems with SNMP3, but I know like all the systems like version 2 is the most common that's out there. Okay, so I think we're getting to like the current world in the past few years. This thing called data center infrastructure management. And what is DSIM? Well, it's kind of like integrating everything, and it gives you more than just the monitoring. You can do a lot of things that are important for like capacity planning, asset life cycle management, uptime and reliability information. Power efficiency is getting big, and this system helps you do that and accomplish that because you're going to have hooks into knowing what all your breakers and all the infrastructure is doing so that you can get the right metrics for power efficiency monitoring and metrics. And this can pull it all together for you. A big thing lately, and it's important for a co-location environment, is to be able to monitor the branch circuits off the PDU that go to the racks. So it's almost like power company metering so that you can tell what power is actually going there, and you can track it and monitor it, and you can actually set up like kilowatt hours of usage off of it. This type of system will allow you to do that and capture that data and control it and give you reports. And it's good for the current generation of data center. And I think if you look at the history of data centers, they're really in the third generation of data center. First generation was just like mainframe type stuff. Second generation was classic hardware, server, you know, network, and still all hardware. And then when VM started to hit, and then with the clouds coming about because of the virtualization, then that's where we're at. We're kind of in the third generation of data centers right now that are evolving. So DSIM is really big out there. This is just a architecture of a DSIM system that we actually have this system. So there's, if we were to dissect this, there's a lot of I/O in there, PLC type stuff. There's all kinds of sensors coming into these I/O capture devices. It's interfacing with all the network cards on all the devices, the generators, the ACs, the UPS, the fire system. And this DSIM system, all the breakers and everything, pulling it all together and able to accomplish what I consider like best in class state of the art, what's going on for data center monitoring right now. I gave a picture of, this is our network operations center in one of our latest data centers. And what we have here are video cameras that we keep up there. In the middle is actually the DSIM system that we use, and it's real neat because you have a graphical representation of the data center. The critical areas that are the data center floor and the electrical infrastructure in the gen area are highlighted green because there's no alerts. When an alert happens, it like turns red, and you can drill down into it and find out anything about what's going on. But these systems also have their network cards so that if this DSIM system fails, I can go to the network card and see what's going on directly with the device. So I always like that second level of monitoring for devices. A lot of times people don't think of it. They just, oh, this is the best, it's primary, it's never going to fail. Well, everything fails, and you have to be prepared for it. We use a program called WeatherBug, and we really like it a lot, and I like it a lot. And this was the first company that I've ever seen it. But go check out WeatherBug. I mean, it's pretty decent for a weather monitoring tool. And then we just have like open tickets and stuff. So I thought that might be interesting for you guys to see how people, you know, set up operations control center. So, any questions about anything so far? Or? Interesting stuff at all? We did have one question come in. I don't know if this individual is here that asked this question, but I thought I'd try to address it. And this is a tough question for me. But I'll answer it kind of how I thought, I would answer it. So here was the question. It says, would Brian be able to address the subtopic of how to appropriately monitor third-party infrastructure and virtual infrastructure? For instance, AWS as a backend for a SaaS application. While Amazon surely conducts its own monitoring, SaaS agreements often require the software vendor to monitor its system in conformance with industry standard for SaaS applications of like architecture. What kind of monitoring, if any, would be suitable or standard in this situation? Thanks. Is the person here that asked this question here? Well, anyways, I saw that and I was like, whoa. I had to read through it a few times. And then kind of my limited knowledge of this area, the first thing I thought about is I wouldn't recommend a tool. This seems like this is a situation where there's a customer, there's the SaaS vendor, and then there's another company on the back end. So there's service level agreements in that chain of command. And I'm thinking, who would use this type of setup? Because I think AWS has limited SLAs that they'll give you. They're only going to be so good. And if I was a SaaS vendor, I wouldn't want to give any more SLA than what I was liable for. So, and if you gave too much, then that could put you in jeopardy. So I'm thinking as an end user, I think you should focus on, instead of tools, don't worry about it. You're paying someone else for that. Get better SLAs, and that company will use better tools to make sure they meet that SLA. So that's kind of how I thought of it. Would anybody else answer that differently?
Got to keep them honest. They can say, oh, well, our numbers show that we're at 99.9, and you're looking at it and say, well, I'm seeing 70% here.
Well, I did a little research about AWS and their SLA, and the first thing I thought is, you have to apply for it to get it. And I'm thinking, that sounds like hard to get. It sounds like dealing with the insurance company or something on that. So I don't have that much experience with it, but I just saw that agreement and I said, it's probably going to be really, really hard to get anything, even though it was whatever their SLA gave, even hard to get. They're not going to come to you to give it to you. You have to come after it. So, but I think, is this a production setup or is this a development setup? Because I think certain things are appropriate for certain circumstances. So I go back again, what are you looking for to do in this situation? Is it development? Is it production? And kind of look, if it is production, what kind of, or even development, what kind of SLAs do you really want? Push that, instead of like, what monitoring tool can I use? We'll put the onus back on them.
The challenge is Amazon generally, first off, you're not going to change their SLAs.
No, you're not.
Right,
but you can with the SaaS vendor, right?
Yeah. So Amazon will take it or leave it. Here's what you get. We have a lot of people that are doing DevOps, for example, or doing development, testing, initial development on Amazon. But you run into the challenge of it's running slow. What do you do? How much you can do. They are the 800-pound gorilla, and they're really, really cheap, which is great until you run into issues.
Yep.
There's other options aside from AWS. There's Azure and other things. So look at what else is available that they the standards that you're looking for, or have tools built in that you need.
I think what's important too is just because you have a third party that's doing hosting for you, and you do rely on the information that they give you as far as reports, it's still important to do your own monitoring for your own sake, for your own records. Just because another vendor's handling it doesn't mean you should just forget about it and just solely rely on that. Because there will be times when you'll have to go back and be like, well, they said this, and I'm not seeing that. We don't have anything on our end to prove otherwise. Exactly.
A really good customer that complained about 9 years ago.
Yeah.
Well, can't you ask for reports, or if alerts happen, that you get those same alerts, that they send an email and log it? I mean,
Depends on the organization. Usually.
So-
It's kind of trust.
Trust but verify.
So I would say that vendors lie.
They don't know.
Yeah, we had several years ago, we were doing an evaluation of Salesforce.com and claimed to be the world's leading cloud vendor. Define it their own place. But literally they had a security breach. And we had 3 different parts of the organization using it. And we were not notified when we inquired. It took a week before they came clean. The IT was from they're not located.
well, you mentioned a thing about compliance, because a lot of the monitoring, I mean, we have to give those maintenance reports and records and what's going on and history of break fix and all that to meet compliance. You know, and we have, I think I have at the end of this, there's just so many compliances out there of all different industries. HIPAA, PCI, SOX, and many others. So, but they're all similar in my mind. They're all asking for similar type things. But all kinds of security out there, and you have to meet that because there's so many breaches.
I think one of the things that's interesting from a monitoring perspective, if you look back in time, some of the older people will remember doing program development back in the 70s when my brother was doing it, and you, I mean, literally cut off the first 2 numbers of the date because he didn't have a program available, right? So that's why he did it, right, exactly. And as computers became more and more powerful, the code got to be bigger and bigger, kind of going back in time to having more and more elegant code. But it doesn't have to be, because we have such powerful machines now that we can work our way through that.
That's cheap.
And, you know, throwing more and more hardware after it isn't always the right solution. So going back to that, I don't want to cut the first 2 numbers of the date off any longer, but you want to get more and more efficient with that.
We save a lot of disk space.
Well,
But it's interesting to see from the back end what you guys are doing from a software development perspective, is especially like the agile process, when your requirements are defined up front, things change from week to week to week and sprint to sprint to sprint. And the IT guys are trying to keep up with, well, wait a second, I had this server with this much RAM and this many CPUs available, and now you change it. They have to be able to change quickly. So the IT infrastructure people, it's really important that they be plugged in along the way. And so once the application goes live, more and more features are added, maybe needs more and more infrastructure to be added. That's where that monitoring comes in handy as well.
That really goes hand in hand with the application performance monitoring. I used to work at Amway, and one of our biggest things was with homegrown code. We always saw crazy performance issues because the code just wasn't elegant. So, you know, end users would say that this interface is slow, the developers would say it works just fine, you know, because, you know, like your initial comment, does the application load? Okay, good. But if it doesn't load fast enough, well, that's a problem. And that comes down to maybe a code issue or scalability on the hardware side. You know, APM can help point where it is.
I always see finger pointing in that. Everybody blames the network first.
Sure. Absolutely.
And network blames application, and everybody goes like this. Yes?
I heard some crazy number, like if the internet was a country, it would be the world's 5th largest consumer of energy.
I do know some energy numbers.
I'm just wondering, yeah, like if you see anything improving across the industry to make data centers greener.
Well, yes, there's a lot of LEED, which I'm not LEED certified, but I started to study for it. That's important. But it's expensive to get that certification. If you go through the building process, it's like, do I want to add $1 million in costs for that? Is it worth it? But those principles address that. But computers use 4% of the electricity in the world, which is actually, it's a big number, but it's not. It's small from an energy standpoint. But it's big enough to pay attention to that you don't want to waste a number. So it's not like a huge number like 30 or 40%, where really, from an energy standpoint, I think the biggest user is like heating and cooling. It's like, I think it's like in the 30% range. So if you want to focus like saving energy from an overall standpoint, you know, I would proportionate 4% of your effort should be there and 38% effort in there, if you really think about it. But
Right, but if you own a data center, the electricity you're burning is a huge cost factor, right?
yes,
And as people are running more and more and more software on more and more servers, I assume that's a cost that's going up dramatically as time goes by.
well, there's a diametrically opposed thing happening, virtualization.
Yeah.
So the last company I worked for, I actually looked at the number of servers, and I'm like, there's a data center within a data center here. If we didn't have virtualization, we would be using twice as much of everything.
Yeah.
So that's, you know.
Yeah, you know, on the computer side of things, Intel has done a phenomenal job of reducing power requirements.
Yeah, it's just not the outside, and it's the servers themselves and what they can do.
But I mean, they're in need of a huge amount of cooling, the 30% number. And so if we can improve the computer itself, we're going to lower the cooling costs as well.
Well, CPUs are getting better, and you can put more stuff on there. They can do more things. So you got these two forces opposing each other. And I actually trend loads in data center, and they tend to do this because of that.
Yeah, yeah.
You know, and it's related to hardware refreshes and what you can do too. A lot of it. It's just not like that. And a lot of times it goes like that, and you're like, how did it do that? It's like, well, we changed all our storage drives. We went to solid state, and we use a lot less energy and a lot more density, and we got rid of all that. And you start, okay, that makes sense. Stuff like that.
So a really new question. Is there an advantage for people that take advantage of having data centers in cold places?
There are a lot of initiatives.
When it gets hot?
Yeah, and it's just not cold places. It's underground places. It's under the ocean. In the ocean. So it's kind of all similar type things because they want to take advantage. Yeah. Atlantis probably did have computers.
If you want to see a cool data center, I don't mean to say anything against online technology, but a wonderful place, but there's a company called Switch out in Las Vegas.
Where's that one?
You heard of Switch? Just go to Switch and Google it. And it's in Las Vegas. It is, I've been through it. I've got a customer actually that moved their data centers from Michigan out there. The real quick story is Enron is going to do to the internet what they did to power. So they were power brokers, literally electricity brokers. But they were going to do the same thing for the internet. So they built this facility in Las Vegas, had every internet provider in the world essentially pull pipes into their facility, and then the feds busted them. So they had this giant, 400,000 square foot data center built, about ready to go. They shut the doors and everything. Well, a gentleman by the name of Rob Roy bought them and built out this facility that's worthy of Las Vegas. The Hummers, that out front, the guys in the security guards, it's an amazing facility. But it's in Las Vegas. That's the first question you ask is, it's hot in Las Vegas. What are you guys doing? Well, these things are...
It's close to Uber dams.
Yeah.
Well, electricity is cheap.
Electricity is ultra cheap. Plus, he didn't have any expenses. Everybody had already brought their pipes in.
Right.
If you put in really super efficient cooling, it's even better.
And he actually worked with Lieber to design their own systems, their own power and cooling systems. They're not available for anybody else. He worked with their developers, with their designers. It's pretty interesting stuff. That it's. I asked the question, why on earth Las Vegas? It's 120 degrees on a cool day.
Well, there's a lot of data centers I've read about and heard about. I know there's one in Europe. It's actually in like a cave.
Sure.
Cool place too.
Grand Rapids down
I think Google was making one that was like portable off in the ocean floating somewhere.
Yeah, floating on.
But back to the original comment, I think there's advantage, free cooling, but what are the negatives? How are you going to get people there?
Yeah.
What about the reliability of the network communications? You're not going to get dark fiber up there. It's going to be so remote, so how useful would everything else be? And so you save money on energy, but it's not really a functional data center. Or it's only good for certain things. Yes?
So we've talked a lot about kind of what to monitor, the network card, the various equipment pieces, how to get the basic information, but then what do you actually do with that information? So I'm interested as to what does Online Tech do? You said you got, what about 5 different data centers? when one of your levers or one of your switches go down or one of your PDUs, give an alarm, what actions happen from that?
Well, every company that I work for that take care of data centers is pretty much the same thing. You don't have people that actually take care of the AC and do the maintenance on, or the UPS or the generators. It's all vendors or ATSs. So you have service contracts. The people that are involved with it know when the alerts come in. So you need to get familiar with what types of alert come in, because you have to triage those so that there's certain things to do. Like a leak detect, there's a lot of nuisance alerts. Well, your program or the person watching this, it might go like this. If it clears within 5 minutes, then don't send the alert out. If you have the alert, someone's got to go check it out. On AC, a lot of alerts are just not really, don't affect the performance, but they need to check out. And then there are critical alerts where, yeah, the compressor's in high head pressure. That means that compressor's not cooling. You got to do something about it now. So there's this whole triage knowledge of alerts, because it's flood of them. So you have to have your systems and people knowledgeable about what do these alerts mean. Okay, what's the implication? Okay, I have 4 ACs, I'm in N+1 configuration, so I can handle 1 AC down. You have to know how your floor is designed too and what it can handle. Okay, but now a second AC goes down, oh, you're in big trouble, because now everything's in jeopardy, because it might go up to 90 degrees where it does impact equipment performance. You have to know your UPS configurations. I got 2 battery cabinets, one's down. It's still critical, you take care of it, you don't ever let that slide, but you're still protected. Now instead of 20 minutes of backup, you only have 10. That's you have to understand the impact to all those alerts. But the process is, those alerts come in, they're triaged, they're sent out, and someone that's responsible has to make that call to get a vendor out there to look at it, and then go from there. Service contracts.
Does the vendor tie into your monitoring system?
I've never did that. They offer that service. I've actually seen that occur, and I don't think that's a good idea.
There's got to be some security issues.
For me, well, there probably is, but for me, it's just like, it doesn't work. When I first got into Ford, HP was monitoring the network. I'd go home and my pager just filled at clear, and they're calling you every single little alert, because it's like, this doesn't work. It's not set up right, it's wrong, it's just a waste of everybody's time. And that's why Ford got rid of them and started to do it internal.
Yeah. There's certain areas where it's done almost all the time. For example, systems that will phone home, storage systems are probably...
Well, IBM is a lot of that, because we would get that, because they're like...
HP, or like drives that would fail, and they're not spinning up right within their algorithms, and then the tech will just show up and say that hard drives to replace them, and before they even really fail. So that's pretty common. But like you're right, networking, other things.
Mm-hmm. Now, a lot of the phone home, a lot of times, I didn't know those systems were set up that they also have phone home type alerts, because we get a call from like the storage people. Hey, my IBM alerted, it says something's wrong with the power. What are you talking about? Well, I gotta go check it out. And it ends up being their power supply and their equipment is what's wrong. The circuit coming in is good, but I have to prove to them.
It's a storage thing, not a...
Yeah, and that's the type of thing that usually happens with like a phone home type situation.
Yeah, I was thinking more in terms of the HVAC level things rather than the computer side of things.
Well, HVAC, I mean, there's some basics that happen. So you have a condenser or something on the outside. If it gets clogged with cottonwood season, it can't reject the heat. You go into high head pressure. So high head pressure means condenser's not working. It's either that reason, or the fans don't work, or you have a leak in the system, it lost its freon.
But that's something you can deal with.
Yes. But a lot of people don't know what high head pressure means. So you have monitoring people, to them, a low suction pressure, which is nothing, and a high head, it doesn't. To them, it's just an alert. But you have to train, whatever your system, if there's other people involved, they have to understand, and they should have a list and triage, and this is what you do, and this is what this means. Yes, you call us, and then the people knowledgeable have to know when to call in the vendor or do something themselves, or whatever your system is for support to fix it.
So, are you aware, or when you have a data center, a bunch of racks and racks of blade servers, do you know what data or information or what vendors or clients are running on those servers? Think about like when your body gets cold, your heart knows to turn off your hands and your extremities first to save your vital organs. Do you have a tier system that like, all right, we're going to shut down the pizza place, but the hospital has to keep running?
Well, I have like 3 responses that I just thought of, different things that you said, because you said a lot of things there. I always try to set up walkthroughs in the data center. It's very, very important, because it's just like someone on a ship in maintenance. Sounds matter. Monitoring isn't going to pick up everything. It might not pick up that leak coming through because it's dripping. When an AC starts to sound different, it might not be alerting, but it's sounding different. It could be because the belt's starting to get loose. So those kinds of things are important. Even how servers and devices sound with the fans. It's like, man, that fan is screeching. Something's wrong with it. Go check it out. So walkthroughs and people in the data center, the same people, monitoring stuff like that is very, very important, because monitoring can't pick up anything, especially if you want to be proactive. Or you can just wait for it to fail.
Monitoring in itself. Monitoring by walking around.
Yeah, it's very. I know there are a couple other things.
But do you know what the data is that's running in your servers, or do you say, it's a black box to us, wherever you want to put it?
No, because I've always been involved where I'm responsible for installs and removals and placing the equipment. So if you have that job, then you know what everything is, or at least you should if you want to do the job well. And it always amazes me on big data centers, there's only a couple people that know where stuff should go or can tell you where it goes. Not many people. And every data center I've been involved with is like that. But it's the people that are responsible for deployments and installing and removal and organizing and planning properly. They know what it is. I know where the network is. I know where core A is, core B. I know where the SAN is, A and B. I know these blade servers are Citrix servers for this application. I know where IPTEL is. I know where the security devices are. Me, personally, I learned that stuff. And you have to, especially when you place stuff. I mean, it's very, very hard to place stuff. I've just seen stuff come in when I first get in data centers. Where should it go? Huh? But,
so do you have an algorithm for I put all the tech stuff together and all the e-commerce together or whatever, or is it like free space, whatever goes next? It's all listed.
Well, the company I work for, there's certain spaces. There's private suites, there's cages, there's colo space. So it's pretty segregated and within there, so it's pretty specific. But I work for big enterprise companies, which are completely different. But in some data centers, what's getting important is if you're using high density equipment, it's very expensive to make all your data center available for high density cooling. You want certain areas for that. So a lot of the planning of the data center is around high density versus low density. Or if you just want to waste money, it's all high density, and then you waste a lot of money in cooling infrastructure. But I mean, there are a lot of different philosophies for organizing stuff.
Do you have anybody that's using like a Google architecture with inexpensive stuff, so high availability?
That I wouldn't know. I mean, how I would answer that though, I mean, I've been involved with disaster recovery. So the best systems I've seen work is there's a hierarchy of like tiers 1 through 7 in terms of a SLA. This we have to have active, with backup. This application we have to be able to restore within 4 hours. This 8, down to 7 that says we fix it when we fix it in place. So there's that hierarchy. So based on that, I mean, that's how I do that.
So how often does something actually important go wrong that you have to go out and fix it in a data center? Is it like every day, or is it like every month, or what?
It comes in spurts, but it can happen at any time.
Usually 3 o'clock in the morning on a Saturday.
It seems to happen that way. But that
In the middle of an upgrade.
well, you have a tier level of a design, And I like to stack the cards in your favor. And so you have this certain design level. And what maintenance does is just maintain that. So if you don't do your maintenance properly or slack, then you're really lowering the design capability. But that's all it is. So I like to have cards in my favor and maintain it, keep it up, and then the odds are in your favor.
Do you see payback there? You don't get those 3 a.m. calls?
Do I see payback?
Well, no, by doing by being proactive, do you see that?
Yes, my whole life is, I always tell my kids, don't let people waste your time or money, and then you'll probably do pretty good. So anything that's an annoyance, I'm like, okay, should it be like this, or can we improve it? Let's fix it so that I don't have to get called in at 3 o'clock in the morning again.
A lack of planning on your part doesn't justify an emergency on my part.
Yeah, but I always try to assess situations for what they are, and if you can do something about it, I'm gonna do it. So anything can always be improved. Sometimes it's a dollar thing, sometimes it's just a people thing and process. It's not always dollars, but usually is, but.
Process is fixed.
Yes.
We've seen
Basics.
real good improvements in people that do proactive type services. The challenge is when you go back and sell to them the next year or the year after that, they're like, well, we didn't have anything go wrong. Yeah. That's why they're not buying it again. I'm like, well, they didn't have anything go wrong because you did the proactive services like that. I don't know.
Well, facilities is like that too. If you do a really good job, no one ever thinks about it. Then when something happens, people just freak out. Oh my God. Because when something happens, facilities, power and cooling, it's bad. It's not good. So I had some more slides here, but I just wanted to point one out because this is like the modern data center stuff in there. But I want to point out at the bottom, doesn't matter, clouds and everything, it goes back to hardware. Physical devices that need power, cooling, fire system security, it's all the same concepts. So it's still there. Just harder to get your finger on it.
Yeah. Do you have OpenStack clients in your data center? No.
Denise might be able to answer that one.
What's that mean?
Need you go.
I'm not very technical, so maybe.
Well, I'm not familiar with that. I know we have a large variety. You know, we're full service. What's OpenStack then? Define it.
It's a, just like open source, it's an open set of APIs for building a full stack, server stack. It's in conjunction with IBM, Red Hat, SUSE, HP.
Yeah, that I wouldn't know. I know we have a lot of people that know Linux and everything, but I wouldn't know what exactly they're doing with it. My first experience with the system that ran Linux, of course we didn't have access to it, but it was a SAN device, EMC device. We're like, what operating system does that run on Linux? I'm like, oh, that's why we don't have access to it.
I mean, it's the idea of having provisioning that you would see from services that comes out, whatever, being able to do that without this license.
Okay, well, we'll take that question back and we can get an answer for you on that. These were just some examples of how things are changing. You know, film is now digital and all that. So the world's changing and monitoring's changing, so that was kind of the point here. Just everything's evolving. And one thing I didn't put in here, but I mean, so building management systems, right, commercial, what's going on with the home? Everything's becoming electronic. You can connect to your home now through your phone. Well, that's sort of a building management monitoring system. At some point, those things are merging to me, it seems like. You know, but homes have very specific monitoring needs. Well, I want to see cameras. I want to be able to lock or open my door. I want to be able to set the burglar alarm or know if it goes off. So it's kind of different things than traditional building management system, but it's all monitoring, it's all remote. So the home's getting really big now with those systems, and you're seeing, I would imagine, software manufacturers are getting involved with that. So
there's a bunch of proprietary solutions out there. We got to get to level 3 before we get a common.
Well, that's what happened with facilities monitoring, because everybody wants to get, you know, I want this, no one else has it, so you're going to have to pay a lot of money for it if you want it. But eventually, as things go, it will be, you know, more open and based on competition, always is.
Price range on those things.
Yeah.
Mm-hmm. Yeah. So I think These are just some stats on how big cloud computing is getting. So you saw this about all the compliances to meet. Really, I mean, that's what I thought I put together that might be interesting for this group. So I don't know, what do we do from here? Any more questions or?